Hello, Assalamualaikum. My name is Amir Ashramil Anwar. My friends and I have prepared this video to talk about Newton's law in everyday transportation. In this video, we will explain the definition of the three laws of motion and its application in transportation technology. Without further ado, let's begin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ari Amal Muhammad Azin and I'm here to teach you guys about inertia. So inertia is the first law of motion. So what is inertia? Inertia is a tendency of an object to resist its motion. So for example, if the object is resting, it will remain at rest. But if it has speed, then it will go with the speed. Whether you realize it or not, inertia occurs every time in our life. For example,
when I stop walking, my body resists the change. It wants to stay still. That is inertia. An object at rest stays at rest unless something forces it to move. But once I'm moving, it's the opposite. My body wants to keep going. If I suddenly stop, I can feel that pull forward. If a box filled with items is at rest and you suddenly push or push the box moves. But the items inside stay in their original position for a moment because of inertia. That is why they seem to slide or fall backward inside the box. When a car is moving, you and everything inside it are moving at the same speed. If the car suddenly stops, your body still wants to keep moving forward. That is inertia. That is why seatbelts are important. They hold you in place and stop you from being thrown forward when the car stops suddenly. Without a seatbelt, inertia can cause serious injuries because your body keeps moving even when the car doesn't. Seatbelt helps overcome the bad side of inertia by keeping you safely in your seat.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Ahmad Zafran Muhammad Khairi. Today I would like to present about the Newton's second law. And the law is just from a one-shot equation, which is F equal to ma. And F is force, which is the push or pull power, and m is mass, about how much stuff an object has, and a is for acceleration, how quickly it speeds off. So that's it. So let's apply it. When you press the gas pedal in your car, the engine provides a force. This force has to work against the car's mass to get it moving. It's that initial push you feel as you are gently pressed back into your seat. That's acceleration in action. Now think about the freight train. It has an enormous mass. To get that huge mass moving, it needs an incredibly powerful engine to create a massive force. That's why it starts so slowly. Therefore, it will take time to gain speed. Finally, the airplane. To lift its giant mass into the air, a plane needs a huge amount of force from its engine to generate the acceleration required to take off. So whether it's a car, a train or a plane, it's all the same physics. To move something heavy or to move something fast, you need a bigger force. Newton's second law isn't just a textbook, it's the force that moves our world. Thank you.
Hello again. Before we go on to the third law, I would like to add something about the second law. As we know that the second law gave us the equation F equal to ma. From this equation, we could derive it into this. What is this equation? This equation is for impulsive force. Impulsive force is a large force that acts for a very short time, causing significant changes in an object's momentum. Usually it happens during collisions or explosions. Now the question is, where does impulsive force involved in everyday transportation? Did you know that cars crash in a specific way? This is actually a safety feature within cars, where there are certain parts of the car that are designed to crumple or crush easily, so that when an accident happens, it will absorb the main force of an impact. These parts are called crumple zones. I will do a simple demonstration. I will be using an empty plastic bottle and an eraser. I will put the eraser on the back of the bottle and tap it like this. I will strike it very hard on a hard surface. This will show you how does crumple zones work. When the bottle makes contact with the surface, the impulsive force will go through the bottle into the eraser, causing the eraser to be blown up. Now I will do it again, but instead I will remove the bottle cap. Without the internal pressure holding up the bottle structure, when the bottle makes contact with the surface, it will crumble. Therefore, the bottle will absorb the main force when coming into impact. That is all from me.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Atun Christian Abubakar, and today I'm going to talk about the Newton's third law of motion. So, what is the Newton's third law of motion? It states that in every action, there will be a reaction with the same magnitude but in the opposite direction. So, I will show you some of examples that we show to you. So, if I push the wall, I will exert some force to the wall, but at the same time, there will be a force that in the opposite direction being forced to me. So, when there is the equal force, this thing does not move. Okay, now, for another example, I will show you that. So, when the police have a gun, so now I have a gun. So, when the police pull the trigger, the bullet will move forward. At the same time, there will be a recoil that moves backwards. So, the force of the bullet will be equal to the force of the recoil. Okay. That is the constant recoil itself. So, how can we see the Newton's law in Newton's relation? We can easily see by with boats. So, as you all know, the boats have Thomas More, which is a kayak or a fishing boat, to a bigger boat, which is a cargo or a cruise. You all know that the cargo is so big and we make it of metal. How can that heavy boat floats at water? So now I'm going to demonstrate with my little boat how can the boat float. Now, if I drop this, you all know that the boat has a weight. So how can the boat fall? It was caused by the gravitational force. So now, what if I put the little boat through water? As you can see, it floats. When the boat floats, because of the buoyant force. So, as you know that the buoyant force exists because of the Newton's third law. So, when the boats have a force which is weight downwards, there is also an opposite direction that causes force to the upwards. Yes. So this is how it explains how the tiny boat tiny boats to float at the water. So I think that's all for me. Thank you.